Hello, everyone, and welcome back to DeFi Central, part 4 of Blockchain Fundamentals. And I have for you here a diagram of what exactly the different layers of blockchain are and what companies represent them. So what we call layer zeros are companies like Polkadot, Cosmos, Avalanche, Cardano, 4 companies that I'm personally invested in. So basically, the ground floor is what we call it. This is where the internet, hardware, and connections exist that allow layer ones like Bitcoin to run smoothly. Layer zeros are allowing several key advancements. So one would be allow blockchains to interact with each other. A great example is Cosmos, which creates an ecosystem of interoperable blockchains thanks to its Tendermint IBC, Interblockchain Communication Protocol. For developers, this is massive. If a dApp can function on one blockchain, it can function automatically on other blockchains. So as long as they're built using the same layer zero. So basically, you don't need to invest any more time in and resources to build the same app on another chain with different coding language. So 2 would be it's faster and cheaper transactions with IBC. Proof of stake consensus can be achieved across multiple chains, resulting in finality times happening almost instantaneously. Finality equals when a block is approved, can't be rolled back, and is considered irreversible. The result is faster and cheaper transactions on cross-chain exchanges. 3 would be infrastructure for developers. Basically, developers don't need to start from scratch and build their blockchains from the ground up. Many features are pre-built and ready to be implemented immediately. So the companies representing layer ones would be Ethereum, Binance, Celo or Cello. I'm not sure how you pronounce that. And then Solana. So I'm personally invested in Ethereum, Binance, and Solana. I don't hold any Celo. I don't really know enough about it. So layer ones are blockchains like Bitcoin and Ethereum that process and finalize transactions on their own blockchain. This is where things like consensus, proof of work, and proof of stake, and all the technical details like block time and dispute resolution take place. The most important 3 aspects of blockchains are decentralization, security, and scalability. And most companies have trouble with the trifecta of achieving decentralization, security, and scalability. So layer 2s would be companies like Optimism, Polygon, Starknet, Arbitrum. So layer 2s are third-party integrations used in conjunction with layer 1s to increase scalability and transactions per second, which is system throughput. When you hear zero-knowledge rollups, ZK rollups, side chains, or anything to do with speeding up transaction throughput, it's likely a layer 2. So layer 3s are basically the decentralized applications that are built on top of the blockchain. So layer 3s is the application layer. This is the UI that we actually interact with, user interface. So here's a diagram of the entire stack, basically. So you have your layer zeros, and on top of that, layer ones, and on top of that, you have your speed and scale layer, and then on top of that, that's where you would where the users actually interact with blockchain technology. So Uniswap is basically where you swap one coin for another, and Decentraland is basically a metaverse game that exists right now. You can go ahead and play it, and Yeah, so let me jump to this article. So, blockchain layers explained. What is layer 0, 1, 2, 3 in crypto? So, layers help us understand and categorize the architecture of a blockchain. Layer 0 is a root layer that allows blockchains to exchange data with each other. Polkadot is a layer 0, for example. Layer 1 is a foundational layer that is responsible for processing and validating transactions on its network. Bitcoin and Ethereum are layer 1s. So layer 2 solutions aim to speed up layer 1s by packaging up a bunch of transactions and sending them as one. This reduces time per transaction and transaction fees. Popular layer 2 tokens are Polygon and Loopring. Layer 3s is the application layer that serves as the user interface. These decentralized applications can be anything from play-to-earn games like Decentraland that we just saw to DeFi apps. Layer 3 cryptos are basically Uniswap or Decentraland. So, the details of blockchain are extremely complex, even on the surface. Underneath the hood, there is even more going on. Blockchain layers are one of those complicated things that, thankfully, normal users do not have to worry about. But understanding layers can help with your knowledge of blockchain, especially while doing your research for certain cryptos, which is important if you are interested in investing. I wouldn't advise investing in anything you don't understand. So every blockchain that exists has a layer that it is built upon. Right now, there are 4 main layers of blockchain. Let's take a look at what blockchain layers are and each of these layers in detail. So, what are blockchain layers? Layers are terms that help us understand the architecture of blockchains, how they are built, and what they aim to accomplish. Blockchain tries to solve the trilemma of security, scalability, and decentralization. This is difficult, however, and most blockchains can only have 2 while missing the third. Each layer of blockchain has different approach to solving this trilemma. So what they're saying is certain blockchains are excellent with security and scalability, but they're not fully decentralized. And then you'll have some that are fully decentralized and they're secure but hard to scale, like Ethereum. And some are decentralized and you can scale, but they lack the security. So basically, every blockchain is struggling with this type of issue to achieve all 3 efficiently. And I would say, I guess, Hedera Hashgraph is one of the best when it comes to scalability and decentralization and security. And I'll do a video covering Hedera Hashgraph soon. So, so each layer of blockchain has a different approach to solving this trilemma. So layer 0 blockchains serve as the root layer, allowing other blockchains to exchange data with each other, even if the blockchains are incompatible. Much like a translator can help an American and a Bengali speak to each other, layer 0s allow blockchains like Bitcoin and Ethereum to speak to each other, even though under normal circumstances they can't. So layer 0 blockchains were created to solve the scalability problem. They bear the burden of validating the data between separate blockchains, while the blockchains validate the data that is sent and received on its own network. So just like any other blockchain, it has its own consensus method, either proof of work like Bitcoin, proof of stake like what Ethereum is moving to very soon, maybe in the next month or so. Layer 0 blockchains have their own token to give as a reward to validate transactions, to participate in the network, and sometimes are used for governance, basically for voting on the future of the blockchain. Layer 0s can have blockchains be built on top of them. These blockchains would be considered Layer 1 blockchains and could do anything a Layer 1 blockchain can do, like mint cryptocurrency, allow users to build dApps, use smart contracts, and more. The blockchains built on Layer 0 could have their own token, method of consensus, and uses. Polkadot is a Layer 0 blockchain because it is a network that allows other Layer 1 blockchains, parachains, to be built on top of it. Parachains can exchange information with each other through Polkadot's main blockchain. If you are interested, you can learn more about Polkadot and how it works. There's a link to that article, so I'll leave a link to this article in the description of the video. So Layer 1s. Layer 1 is the base blockchain layer. It is made up of a network and its tools. This layer is responsible for recording transactions sent over its network and coming to the consensus that they are valid. That is the basic blockchain process. This layer is responsible for checking things like wallet addresses, public and private keys, and token balances. It's also responsible for choosing the consensus method of the network. The two main consensus methods are proof of work or proof of stake. Proof of work is what you think of when you think of mining cryptocurrency, which means that miners on the network race to solve complex problems in order to validate the block, in order to validate and receive new cryptocurrency tokens. This is extremely secure but incredibly slow. Proof of stake is when users lock their crypto holdings on the network in order to be given a chance to be randomly selected to validate blocks and receive rewards. This is fast but less secure. So basically, to rewind a bit, like I said before, proof of work is what Ethereum was originally working on. That was their consensus mechanism, and now they're doing a merge to basically switch to proof of stake because Ethereum is having issues scaling, and their gas fees, which is transaction fees, basically are really expensive because the network gets clogged because there are too many transactions that need to be processed and not enough processing power. So they need to merge to proof of stake in order to scale. And that's a completely different consensus mechanism, basically how they process transactions, and basically it's done through staking. So moving on, Layer 1 has services like peer-to-peer payments or smart contracts, and the token is used to pay for the network's services. The token is earned during the consensus process, whether through proof of work, proof of stake, or some other method. Bitcoin is the most popular Layer 1 cryptocurrency. It is also the most popular by market cap. Bitcoin is a digital currency that can be sent to users over its network. Bitcoin uses a proof of work consensus method. Another popular Layer 1 blockchain is Ethereum. It is the second most popular cryptocurrency by market cap. Ethereum is different from Bitcoin in that it is a software platform that makes use of smart contracts. That means applications can be built on top of Ethereum, but We will get into that in a second. Ethereum also uses proof of work consensus mechanism. So that's it. Basically, Bitcoin is more just as a store of value and digital gold, because basically you can't run smart contracts on Bitcoin. So that's basically Bitcoin's not a smart contract platform. Other common cryptocurrencies that use layer 1 technology are Cardano, Solana, Avalanche, and Algorand. To name a few, there's tons of others. These cryptocurrencies use a proof of stake method of consensus. So layer 2s. Layer 2 is a framework that is built on top of an existing blockchain with a focus on speed and scalability of the main blockchain. The main idea behind layer 2 is to take transactions off of layer 1. Instead, transactions are processed on layer 2 and then sent to the layer 1 blockchain. Since layer 1 cryptocurrencies like Bitcoin, 4.6 transactions per second, which is not a lot at all, and Ethereum is doing 15 transactions per second, are slow to process transactions. Fees can be extremely expensive during times of high demand. Ethereum's gas fees were once as high as $200 worth of ETH, and that's true. Layer 2 networks are designed to help overcome that problem by being able to process thousands of transactions per second. So layer 2s help layer 1 blockchains by increasing scalability and decreasing energy used, which is important for the environment also. And I should also mention Hedera Hashgraph is the most energy efficient and actually carbon neutral when it comes to their consensus mechanism. So more on that in later videos. So that's it. So basically, layer 2s help layer 1 blockchains by increasing scalability, speed, and decreasing energy used, all while keeping the security, decentralization, and transparency of the main blockchain. There are a few different ways that layer 2 solutions work called rollups, ZK rollups. The main ways are optimistic rollups and zero knowledge rollups. They achieve the same basic thing, which is to take a bunch of little transactions and package them up and send them to the main chain as one transaction. Optimistic rollups are smart contracts that receive transactions that are verified by validators on their network through their own method of consensus, mainly proof of stake. Once the contract has enough transactions, they are sent to the main blockchain as one large transaction. The whole process is completed on the main chain. This means low gas fees and increased scalability, but means longer withdrawal times. Through that means nothing to the end user. So basically, that's all just amazing for scaling on proof of work blockchains. So zero knowledge rollups, ZK rollups, can be completed on chain and off chain. On chain takes advantage of smart contracts, which will store both accounts and balances. The transactions themselves are done off chain, sometimes using a different token to pay for transaction fees. Again, once enough transactions have been processed, they will be sent to the main chain. This means near instant transactions, lower gas fees, and less vulnerability to attacks. So the Bitcoin Lightning Network is a very popular layer 2 solution for Bitcoin, basically. At times of high demand, it can take hours to process a Bitcoin transaction. Many believers think that Bitcoin will become the world's currency in the future. But that won't work if it can't even process 5 transactions per second, that's for sure. Just to compare, Visa can process something like 20,000 transactions per second. Thus, the Bitcoin Lightning Network was created to scale Bitcoin. This off-chain network packages up Bitcoin transactions between users and then sends them to the main Bitcoin blockchain. There are a few popular layer 2 cryptocurrencies. My 2 favorites are Polygon and Loopring. Polygon aims to speed up transactions over the Ethereum network and uses ZK rollups to reach up to 65,000 transactions per second. Loopring also attempts to scale Ethereum by allowing users to build decentralized exchanges and make use of ZK rollups to allow thousands of transactions per second at the cost of less than a penny. So that's just amazing. Layer 3s. So finally, layer 3. Finally, the last blockchain layer for now is layer 3. This is the application layer. These decentralized applications, dApps, are usually built on layer 1 or layer 2 and are visual tools that allow users to interact with blockchains. Basically, layer 3 is the user interface that they help create real-world uses for blockchains. Applications on layer 3 use smart contracts and can be anything from decentralized finance to decentralized exchanges to NFT marketplaces to play-to-earn games to storage apps. It's like downloading an app off of the App Store, basically. You can interact with the application without knowing anything about the code running underneath. One of the main selling points of layer 3 is cross-chain functionality, which means that users can exchange data from multiple blockchains on a single application. Similar to layer 2s, these L3s, these L3 apps will process transactions on their own platforms and then send them to the main chain when needed. Only certain layer 1 networks allow layer 3 applications to be built on them. For example, Ethereum and Cardano allow applications to be built on them, but Bitcoin does not because it was never designed to do that. So some popular layer 3 cryptocurrencies include Uniswap, Yearn, SundaySwap, Aave, Decentraland, and the Sandbox. And that's just a tiny fraction. So, summary. Blockchain layers are a way to help us understand how blockchain is built and run. And like I said before, if you plan on investing in this stuff, it's best that you know exactly what you're investing in. And for me, the more I research about blockchain technology and what it's created to do, is the more I am committed to it, and the more that I basically believe in it. Basically, so so layer 0 blockchains are those that allow exchange of data between other separate blockchains or allow blockchains to be built on top of them to take advantage of their scalability. Polkadot is a popular layer 0 blockchain, and that's one of my favorites too. I'm heavily invested in Polkadot. So layer 1 blockchains are a foundational layer that is responsible for validating transactions sent across its network. Bitcoin and Ethereum are the most popular layer 1 cryptocurrency. And I should also mention that the founder of Polkadot was also one of the founders of Ethereum. And the same thing for Cardano. Cardano, the founder of Cardano, was also one of the founders of Ethereum. So, so layer 1 blockchains are a foundational layer that is responsible for validating transactions sent across its network. Bitcoin and Ethereum are the most popular layer 1 cryptocurrencies. Layer 2 solutions are solutions Layer 2 solutions are a solution to layer 1's scalability problem. They wrap a bunch of transactions into one and then send that to the main chain, which improves speed and reduces cost for the users. Polygon, Loopring, and the Bitcoin Lightning Network are popular layer 2 solutions. Layer 3 is the application layer. This is the layer that the end user will see and interact with. The applications built on this layer can be anything from decentralized applications to DeFi, which is decentralized finance, to play-to-earn games. I'll start over. Layer 3 is the application layer. This is the layer that the end user will see and interact with. The application built on this layer can be anything from decentralized applications to decentralized finance to play-to-earn games. Popular L3 cryptos are Uniswap, Aave, and Decentraland. So, I'll leave the link in the description to these two articles in case you want to read them over again. So that's it for today's video on the different layers of blockchain. So I hope that was informative. I wish everyone the best, and thank you very much for watching, and I'll see you in the next video. Thank you.